What I've got here is the Canadian version of the RCA AF020J, which is called the TP6512AU in Canada. It is a portable style black and white TV with a two-tone plastic cabinet, VHF and UHF tuners, and an approximately 12-inch screen. The chassis is type KCS152A. In this video, I'll be restoring this TV to working order. A little backstory behind this TV. I saw it for sale. I went to visit. It hopped in my back seat and would not leave. It just said, "Mr. Brown, I love you, I love you, I love you." So I could not say no. I had to take it home with me. And here we are in Mr. Brown's basement. It is complete with its knobs, which is great. But some stuff has been done to it. I don't know why. Two holes have been melted in the back. There is one screw, or perhaps two screws, missing, and something else here. This antenna is great. It's intact. Looking at the back, it uses just a standard TV power cord, but it's missing a few things that need to be repaired here and there. I haven't opened this up before. We're going to open it up now and see how it looks. Yeah, there's probably a screw missing there too. One thing I'm going to do with this set, which I don't normally do, is power it up through a dim bulb tester. I don't usually bother powering up an unrestored set due to the risk of damaging it, but for the YouTube community that is interested, I'm making an exception this time. Whoops, my TV is already smoking. A dim bulb tester is a simple piece of test equipment used to limit current to a set under test. It involves putting a large resistor between the power supply and the set. The resistor used in a dim bulb tester is usually a 60 or 100 watt incandescent bulb. The idea is that if there's a short circuit somewhere in the set, the excess current will be dissipated by the bulb, causing it to glow dimly, rather than causing damage to the set. Okay. I think I have a better solution. My dim bulb tester lacks a dim bulb, so I call it a not a dim bulb tester. At the bottom I have a meter to tell me how much current is being drawn, which is a good thing to know, because if something is going wrong, I want to see it. Instead of using a bulb, I use a couple of huge power resistors, which are in this metal enclosure, in fact synced to this metal enclosure. And I've got a switch, which allows me to switch in or switch out the series resistor. Why not just use a bulb? And that's because a bulb has very low cold resistance. It jolts the circuit with a very, very high current for the first few dozen milliseconds. This is plenty of time to do damage, especially when semiconductors are involved. The alternative would be to use a variac and power it up that way. If I had to power it up, that would be my first choice, but we're going to try my not a dim bulb tester. The chassis is live, so don't grab the chassis and then touch something grounded, because you have a 50% chance of something very bad happening. Okay. Right. And as expected, 0, and it's in the series resistors setting. The on-off switch is usually connected to the volume. So let's try. It is drawing nothing. Oh, it's drawing something. The current is down to 0.1 amps. I'm not going to give it the full line voltage. Nothing. Absolutely nothing. Now it's even lower, down to 0.09, 90 milliamps. So no, it is not heating up. Nothing is happening at all. I'm curious. Ooh, that's a little warm. There are several clues that somebody's been in here before. First of all, the high voltage cage is partially open. It should not be. The 4 screws that held it together are all different. And this is all chewed up. This set, most of the guts lives on this one printed circuit board. There will be a little bit of point-to-point wiring underneath these power tubes over here, but most of the goodies will be right over here. In sets of this vintage, there will be many fewer paper capacitors. There will still be some, but the industry was migrating to film capacitors, like that green one in there, that shiny green one. This one is probably paper, this red one, but these are film. It was a matter of price, what was available for the least amount of money. They did use carbon composition resistors, and they will all have to be measured. You can see right there. My goodness, this cathode ray tube has a very short neck. It's maybe 5 inches, no, not even. Maybe 4 inches of neck. To determine whether this set is worth fixing, I need to find out if the picture tube is any good. And to do that, I will use my Sencor CRT tester. I want to be able to see if the CRT is lighting up and see what kind of emissions I'm getting. First step to testing it is finding it in the book. It's a 16AYP4, which is right there. It uses socket number 4, and these are the settings. I've set the filament, cathode, and grid connections according to the book. Let's turn it on. We need to adjust it up to 6.3 volts. Filament is now receiving 6.3 volts. And let me turn down the light. Okay, yes, it's glowing. It's glowing very nicely. Okay, heater cathode shorts. No problem. Grade 1 shorts. No problem. Cutoff. Okay, we have to get it into the box, which it is. Emission is good. What I have here is a tube that appears to be quite strong. I'm wondering perhaps if it's not an original tube. We'll find that out when it's all taken apart. But first, the other tubes need to be tested. After testing the tubes, I've discovered that the high voltage rectifier is bad. This is the video output. That is bad. Actually, it's weak, but it's bad enough to be bad. And this is the RF amp from the tuner. It's bad. This tube, 15KY8. I can't test this because my tester doesn't do 15 volt tubes. 15 volt tubes that are really 15 volts. This is actually 15 volts. Fortunately, I have a couple spares if I need them. In series with B+ is this RCA 4 which is a 0.35 ohm fusible resistor. It looks like a wire wound resistor, but it's basically a fuse. And it is good. It would affect the B+, but it could not affect the filaments. Let's look at the situation with the TV's back cover before going any further with the chassis. It's all washed now. Unfortunately, it's stained and, of course, faded due to the kind of plastic it is. I'm concerned about these holes because they're just ugly. What I'm thinking perhaps is just to cover it over with hardening putty, same over here, and perhaps match it down below so it looks like a feature of the case rather than somebody's awful experiment. I'm not sure if there's supposed to be a hole there, but that looks awful. The rest of the case, except for one spot right there, is not too bad. You can see the color of the case was originally before oxygen got to it. Yeah, well, it's looking a lot better than it did before. Okay, that is rust that from the chassis that has stained the porous plastic. Not a big deal, not the most beautiful thing, but it's on the inside, so nobody's going to see it. The holes are gone. The plugs are permanent. The color is close. I wasn't entirely happy with the color of the patches, so I went to a paint store and picked up some Benjamin Moore butter cookie paint, and that should match the color of the case very, very closely. We'll see how that turns out once the paint is dry. It's a little shinier than it should be, but that's because I put some polyurethane on to protect the surface. As a match, I can live with that. I'm putting the back case back together. I've repaired this mess that had been on the antenna. It had been wrapped with steel wire. I guess whoever serviced this before couldn't get this joint hot enough to melt the solder. I put a copper wire on. You can see the patches I made from behind. They're not as beautiful from behind as they are from the outside, but that's okay. Nobody's looking on the inside. This case is held together with speed nuts. There are a total of 5, and 2 of them are missing. So I will have to acquire another couple speed nuts. And then I can start concerning myself with the chassis. These number 8 speed nuts seem to fit quite nicely. Not perfect, but well enough that I'm not going to complain. And I would complain if they didn't fit properly. They hold well, and that's the important thing. I'll leave a link to this particular speed nut in the video description. With the TV on its face padded, I can take out the chassis. It appears to be 2 1/4-inch bolts in the bottom corners and 2 5/16 bolts at the top. And then I've already got the speaker disconnected over there, and the high voltage anode is disconnected over there. It just should be a matter of slipping it out. So the tuners, there are 2 tuners, disengaged from the holes at the top. There it is with the chassis removed. Cabinet is in good shape. I'm glad to see no cracks, because cracks could mean that the picture tube was unstable. Genuine RCA picture tube, 16AYP4. This cabinet will not stand as it is. It needs the chassis to support it. To clean this case, I'm going to remove the picture tube with this TV. It's just 4 hex head bolts. Also, the strap that goes around the tube is a thick metal wire. It's not spring-loaded, which makes it much easier to deal with. The trick is record how the tube is mounted and put it back exactly the same way afterwards, without over-tightening anything, without applying pressure to anywhere on the tube. Most fragile part of the tube is the neck. When I clean the case, I don't want the chance of hitting the neck and having something bad happen. The tube actually can go in either way, but if you put it in the wrong way, the high voltage connector here will be too far away from the high voltage cage and the wire won't reach. So it must be on this side. Just because I'm careful, I'm going to be using gloves and face protection. If something goes south unexpectedly, I will not be harmed. And it's out. I will have to take off this bracket which holds on the handle and the speaker and the adjoining bracket, and then I can wash the case thoroughly. There's the CRT, complete with its rubber bumpers in the corners. I'm going to use a grease cutter to take off a lot of this dirt and grease and grime, but nothing abrasive. Abrasive will take off this metal finish, and there's no easy way to reapply it. I'd rather it be a little dirty than lose that very 60s grill effect that's here on the set. Here's the back side or underside of the chassis. Very appropriate expression is nothing to see here. These capacitors here, I've broken them open to see what's inside. They're plastic. There might be exceptions, but they're most likely plastic based on my experience. there's an electrolytic. Looks like it has 3 sections. Gotta go. That doesn't look too bad. It's amazing how much the circuitry was simplified by this time. It's mostly resistors and capacitors to replace, just this one I noted before. This is a thermistor. If that's bad, that would prevent the TV from working for sure. Barring any unforeseen surprises with, let's say, the flyback transformer or some part that cannot easily be obtained, this looks like an inexpensive TV to get working. As in, not a lot of parts, like maybe a handful of capacitors. Who knows how many resistors, but the resistors are probably mostly okay. Glad it jumped into my car. One last thing for now. Look at that. There's some sort of liquid that's at the bottom of the tuner. Is it possible that somebody sprayed the heck out of it with some sort of cleaner, that it's still pooling? Or maybe something leaked. Interesting. Well, whatever it is, it doesn't dribble, because if it did, with the tuner being upright, I would see it over here, and I don't. This piece of cardboard with all the holes in it is not decorative. The whole idea is that it will give you access to those tuning slugs if you need to align the tuner, and you can do it without taking out the tuner, which is a good design. This is an unusual tuner in that the fine tuning is accomplished with this knob, which is next door to the channel selector rather than concentric with it. This circuit breaker here is flaky. It sometimes makes contact, but most of the time it doesn't. The circuit breaker, which reads at best about 17 ohms and at worst infinite, cannot be trusted. I will probably end up replacing it with a fuse instead of another breaker. I might be able to acquire one of these breakers, but I doubt it. It would just be better to have a fuse here. Probably slow acting. I'd have to check the circuit to see how many amps. It won't be a lot. Made in Canada by United Car for Melrain with a patent number. Let's take a quick peek inside. As expected, it's a bimetallic strip, but that lower contact looks tarnished, which is probably why it's a fairly high resistance. And of course there's the remains of a spider house in there too. That probably didn't help. As mentioned before, this is the line capacitor. It should be a safety type capacitor, so it's going to get replaced. The new ones are much smaller. This connects to the fuse, so I'm thinking putting in an inline fuse holder here, or mounting something like this old style fuse holder out there to see what works best. I'm testing out the resistors on the underside of the chassis, plus the ones on the printed circuit board, and most of them are okay. But here's an example of one that isn't. There's a yellow, violet, black, which is 47 ohms, and no fourth band. That means plus or minus 20%. That means this resistor could still be good if it's anywhere from about, 37 ohms to about 57 ohms. But when I'm measuring it, I'm getting almost 65 ohms, which means it's bad. When you test resistors in circuit, as I'm doing here, all you can get is the least resistance. You can't know the maximum resistance because there could be something else in parallel with it. Ideally, you disconnect one end of them to make sure that they're not in circuit at all and test them that way. R210, that 47 ohm 5% resistor, is measuring 68 ohms, which is way out of 5%. Since this is a cathode resistor and tends to get warm, I've upsized the resistor to 1 watt, and I've also mounted it about 1/4 inch off the board so it can dissipate heat better. Generally speaking, the resistors that fail in this set are resistors that run hot, which are typically cathode resistors like this one and this one. And I think there's another one somewhere. There's another one on the underside. And anode resistors, that would include this resistor right over here. All the other resistors tested in circuit appear to be working and within tolerance. In the race to the bottom of price, manufacturers got real cheap on tube shields. So instead of being like a chimney, at this point it was just a cylinder soldered down to one grounded pad, and that was all that held it in place. That's fine, except traces aren't very strong unless there's a lot of surface area, and there isn't here. With this tube, that trace had broken, so there was no path to ground. All it needs is a low impedance path to something ground dead. Not fancy, but it will do the trick. And actually, it's more secure. I'm really wondering what's going on with this stuff here. I don't know what this stuff is, but it shouldn't be there. It's not flux. It certainly shouldn't be oil. To get to that, I'm going to have to take out the tuner. Fortunately, it looks like it's just being held in with a couple bolts. Make that 3 bolts. There's one on top. Whatever that stuff is, it's not actually in the tuner. I'm thinking that maybe whatever it was might have dripped in from outside. Alcohol and Q-tips has removed most of it. It shouldn't be there. This may be the reason why the dim bulb tester didn't bring the TV to life. This is the on-off switch, and it's flaky at best. Sometimes it reads high resistance. Sometimes it just reads open. I'm going to have to take apart the switch. The switch is held to the volume control body by these little clamps. You can undo them once, maybe twice if you're lucky, but after that, no. They're not meant to be opened and closed very many times. So I'm going to pry those open and separate the switch from the volume control body. I think the way it's supposed to work is that when you push in the plunger, it spreads out this spring and touches the contact underneath this end of it. Here's the contact, and you can see it's chewed up quite badly. And the contacts inside, yeah, they're chewed up as well. But this is repairable. If the plunger doesn't want to stay on that shaft, I don't know what to do about that. Can't say I'm entirely happy with the operation of the switch. If I can find a replacement, I'm going to order it. I thought about mounting the electrolytic capacitors off the printed circuit board, but I decided I prefer a terminal strip. So that's what I did. I screwed it on there. Now it's firmly in contact with the chassis. That's the negative terminal. But I put in a wire to ground anyway, just to be 100% safe. New rectifier and new thermistor. A few weeks later. This is not my preferred way of acquiring components for an old set, but sometimes there are no choices. Genuine RCA service part, 113427, 1 mega ohm. Can't read the rest, but this should be a new volume control for the set with a switch. But before I install it, I'm going to test it because it may have the same issue that the other one has, which is just advanced age. I think it works, so I will go ahead and take out the old one. The replacement did not come with hardware, so I will reuse this nut. There are 5 wires to desolder and resolder, 2 for the switch and 3 for the potentiometer. Here's a comparison of the new control and the old control. This one here, the original, appears to be Centralab. I can't tell who made the one on the left. Very different switch, hopefully a more reliable one. These contacts are tinned, but these are not. In fact, they're tarnished and solder won't stick to them as readily. So a good idea is to brighten them up with some emery cloth or sandpaper before soldering to them. I'm going to power up the set without the deflection yoke installed. On pins 6 and 7 of the deflection yoke, if it's not plugged in, the connection to the low voltage power supply is broken, which means that anything connecting to the 140 volt B source won't be powered up, which is anything in green, which is the horizontal output tube affecting the 260 volt boost, the 480 volt boost, and the voltage to the high voltage anode. The vertical output will still be powered up because it gets its power from the 140 volt A source in orange. The chassis is still live, but there's no 17,000 or whatever volts on the high voltage anode that I have to concern myself with. For testing this, I'm going to connect up a speaker on the speaker connector. I'm going to go to the power supply and hook a voltmeter onto the B+, make sure that I'm getting 140 volts. No reason that I shouldn't be. And turn it up with a variac, make sure I don't get any magic smoke, which would be very undesirable. And listen for sound through the speaker. If I get all those things, then I will go to the next stage and hook up the deflection yoke and the picture tube and see if I get a picture. Speakers hooked up to audio output transformer. Voltmeter is connected onto B+, in this case 140 volt A source. Power is going to connect into the variac, and I've got a jumper where the CRT filament would be, so I have continuity on the filament string. All the tubes are in, the deflection yoke is not in. What I'm hoping for is for the tubes to light up and see roughly 140 volts on the meter. I would expect to hear the oscillators running, the horizontal and vertical oscillators running, and eventually hiss through the speaker with my brand new spiffy volume control. Chassis is live, but I don't actually have to touch it to adjust the volume control. Actually, there's a 50% chance that the chassis is neutral, but I'm going to work as if it were live. Getting hum from the speaker, around 102 volts, 140 volts on B+. I think I have hiss. Everything smells okay. It smells like warm tubes. If you have smelled it before, you know what it's like. Yeah, I think we're ready to go to the next step. TV's back in its cabinet, connected up to the variac just in case. Deflection yoke is hooked up. High voltage lead is hooked up. CRT socket is hooked up. I think we're good to go. And it powers up. That's with 110 volts going in. I'm getting some vignetting here and here, and at the bottom too. That could be the centering magnets, or it could be the yoke not pushed up all the way. But since I didn't move the yoke at all, I don't think it's a case of the yoke not being pushed up. I take it back. The deflection yoke had slipped about 1/4 inch down the neck. And now that it's pushed all the way and tightened, the raster fills the screen. That fills the screen and it's quite linear. Not bad. Oh, if you excuse the noise, which is my crappy RF modulator, that's not a bad picture.
The solution is not old enough for Libya. I say, wipe out Washington and New York.
What? Spoiled 3 years of good public relations? I have the Americans believing I am a nice guy. Some of their polls, I'm more popular than their president. Gentlemen, this is getting us nowhere.
I could probably go in and touch up the IF alignment to improve the picture and sound, but it's still quite watchable as it is. I hope you enjoyed this video from Mr. Brown's basement on the repair of the RCA AF020J or TP6512AU. Please like and subscribe, and I hope you'll tune in for more videos in the future. Thanks for watching.